Hi, welcome to the Machine Learning Libraries lesson. This lesson is based on the first notebook of the course. In this lesson, we are going to learn some Python libraries that are commonly used when building machine learning solutions. In particular, we are gonna see Numpy to work with n-dimensional arrays, Pandas to import, analyze, and manipulate data, visualization tools like Matplotlib, Seaborn, WordCloud, and Volume, and a brief introduction to other libraries like Keras and Scikit-Learn. You will learn more about Scikit-Learn in the next lessons of this course. Numpy is a very useful library used for numerical computing with Python. It is commonly used to work easily with n-dimensional arrays. You will often use it while building machine learning solutions. To import Numpy, you have to write this line of code. Let's see some ways to create a one-dimensional array. We can use the array method, specifying the values of our array. We can use the linspace method. In this case, we have to specify the starting and ending numbers of an interval, 0 and 9, and the number of values that we want within this interval. Here we also specify that we want an array of integers. Another way is to use a range. In this case, we have again to specify an interval and then the step size between consequent values. Note that, by default with a range, the maximum value of the interval is not included in the output array. Let's see some useful information about a one-dimensional Numpy array variable. With the type method, we can see that the variable is of type numpy.ndArray. The dType attribute of the variable is useful to check the type of the elements of the array. The size attribute tells us the total number of elements of the array, while the ndim attribute can be used to check the number of dimensions of the array. It is very common to use the shape attribute. In this case, thanks to the shape, we can see that we have a single dimension containing 10 elements. To create a two-dimensional array, we can use again the array method. Let's see what changes with two-dimensional arrays. The size attribute tells us that there are 6 elements. Thanks to the shape, we know that we are working with a matrix of 2 rows and 3 columns. The indexing is very easy, just like the Python list indexing. Also, slicing is nothing new for a Python programmer. Just remember that we can pass 3 arguments to slice: start, stop, and step, and that we can also use negative indices. These are some basic operations between 2 one-dimensional arrays. It is quite common to broadcast an operation among all the elements of the array, as you can see here. Of course, it is also common to compute the mean, the maximum, or the minimum of arrays. Here instead, you can see some basic operations with matrices. We can specify the data type of the elements of an ND array when we build it. As you can see, we can also cast its elements after its declaration. To copy a Numpy array, we can use the copy method. As you can see, if we change the first element of the copy, the original array is not affected by this. The shape of an ND array represents the number of elements in each of its dimensions. We can change the shape of an ND array with the reshape function. Let's start with a one-dimensional array containing 12 elements. Then, we reshape it to obtain a 3x4 matrix. Here instead, we reshape the one-dimensional array into a 3-dimensional array. This ND array will contain 2 3x2 matrices. If we don't know how many elements there are in a specific dimension, we can use -1 and Numpy will compute this for us, if possible. In this case, we want to obtain as many 2x2 matrices as possible, starting from the original array. we can reshape it into 3 of these matrices. If we want to flatten a multidimensional array, we just have to use the -1 as the argument. In this way, Numpy will reshape the multidimensional array to a one-dimensional array containing all the elements. Let's see now how to join two Numpy arrays. To join one-dimensional arrays, we can use the concatenate method. We can join two matrices along the rows or the columns, always with the concatenate method. The concatenation along the rows is made by specifying the first axis. In this way, Numpy will concatenate the columns of the second array to the first one. The same result can be obtained with the horizontal stack method. The concatenation along the columns is made by specifying the axis 0. In this way, Numpy will concatenate the rows of the second array to the first one. The same result can be obtained with the vertical stack method. The sort method is used to sort the elements of an array, based on their type. To filter an array, we need a list of booleans. In this way, we filter out the elements corresponding to false indices. We can now move on and start to talk about the Pandas library. Pandas is a tool used for data analysis and manipulation. This is the code to import it. Pandas works with dataframes, two-dimensional data structures like tables. We can create a data frame from a Python dictionary in this way. You can see that the keys of the dictionary are represented by the columns of the data frame. The columns are also called attributes. On the other hand, each row is associated with an increasing index that starts from 0. We can create a data frame starting from a CSV file that we have to load and read in this way. In this lesson, we will load different datasets with Pandas. Here, for example, we load the movie lens dataset with TensorFlow datasets. The movie lens dataset contains 25 million movie ratings. With this code, we just load the small version of the dataset and convert it to a data frame. We can use the head method to display the first 5 rows of the data frame. Note that the movie genres are identified with numbers. Furthermore, the columns movie ID, movie title, and user ID contain bytes object. We can cast these columns to string. To cast the values of a byte column to a string, we can use the decode method, as you can see here. By applying the decode method to the byte columns, we obtain this data frame. The info method is useful to read some information about the data frame. For example, we can see the number of entries and columns of the data frame, the names of the columns, and the memory usage. Let's see now how to select specific data from the data frame. With the integer location method, we can specify the data frame rows and columns that we want. In this example, we select all the rows and the first 2 columns. We can also specify the name of one or more columns. Sometimes it can be interesting to see all the possible values within a specific column of the data frame. We can also filter out data frame entries. Here, we want to find all the entries in which the user rating is greater than a certain value. At the same time, we can also specify what columns to see. In this case, we leverage the lock method and use the slicing to select the columns from movie title to user rating. Here, we specify only 2 columns without slicing. Let's see how to compute more complex filtering operations. Here we find all the entries in which the movie title string ends with 1997 between brackets. Here we apply a lambda function to the movie title column values to find the entries in which the movie title string contains 10 words. Finally, here we combine two filtering operations, and then we select the column's movie title and user rating. Let's see now how to add new columns to a data frame. In particular, we want to add a specific column for the movie year. The data frame contains some entries in which the movie year is not written in the movie title column. We have to consider this when we create the new column. We want to create the years list that contains the values of the new column. First of all, we use a list comprehension to take from the movie title of each entry the last 5 letters. The strip method is used to remove spaces at the end of the titles. Then we loop over the years to convert the string years into integers. Note that each element is sliced until the last letter, which is supposed to be the closing bracket we find in the titles. If this operation is not possible, this means that the title did not contain the year between brackets at the end of the string. So we consider these cases as not a number. Hence, we can insert the year column by specifying its column index, 3 in this case. We also cast the type of the column to integer. With the isNA method, we can check possible not available values within the year column. As expected, we find some entries with this problem. To solve this problem, we can just use the dropNA method. The in-place argument is used to update directly the data frame on which the method is called. Instead of removing rows with NA values, it is possible to fill these cases with the fillNA method. We don't need it, but we could fill possible NA values in a user rating column with the mean rating of the dataset, for example. To drop a column we are not interested in, we can just use the del keyword. Let's see now how to convert the timestamp column into a date column. We just have to use the toDateTime method and specifying the timestamp column and the time unit used within the column, in this case seconds. Then we use the rename method to change the name of the column from timestamp to date. Now we want to remove the year from the movie title, since now we have this information in the year column. First of all, let's define a filter that takes the movie title column values, applies the strip method, and checks if the string ends with a year between brackets. Then we use this filter with the lock method, selecting only the values under the movie title column. In this way, we obtain a data frame with a single column. We apply the squeeze method to this in order to obtain a Pandas series. To a Pandas series, we can apply a map function that removes the last letters of each string. On the other hand, it is very easy to remove all the entries of the data frame with a specific movie title. Another thing to do is removing the duplicate entries. With the duplicated method, we can find the entries with the same values on the specified columns. Here we use keep equals to false to maintain all the duplicates, since we want to see how many duplicates we have. After that, we can use the same idea, but now we use keep equals to first in order to keep only the first duplicate of each case. Pandas provides the plot method to visualize the data frame data. Here, for example, we plot the histogram related to the year column. The last thing to do is to save the current data frame into a CSV file. The first visualization tool we are gonna learn is the Matplotlib library. This is how you can import it. To play with the library, we are gonna use the Boston house prices dataset. It has been collected in the 70s and it is provided by the Scikit-Learn library. Its records contain 13 features of houses with a corresponding price, expressed in thousands of dollars. This is how we can import it. Note that the price is encoded by the target column. The other columns represent the house's features. For example, the RM feature is related to the habitation rooms, while the LStat feature is related to the percentage of the lower status population that surrounds the house. This is somehow based on the socioeconomic status of the population. For the following plots, we are going to consider only the RM feature data and the target prices of the houses. First of all, we use pyplot to create a figure. The fixed size argument defines the width and height of the figure in inches. Then we ask the library to plot the features. By specifying a single argument, the plot function will consider the values as the y values of the plot. The x values are created automatically from 0 to the length of the features array -1. Then we remove the ticks from the x-axis, since they are not important, and finally ask the library to show the plot. Note that line plots are typically used to plot temporal data, so in this case it is not very useful. We can also fill the area below the line with the fill between method. The x argument requires the same x values of the previous plot. The y1 and y2 arguments require the y values between which we want to add the color. Different arguments can be used to change the points of the line style, the line width, and the line color. For the points, we can also use other arguments. The marker size, ms, the marker edge color, mec, and the marker face color, mfc. To plot multiple lines, we just have to call more times the plot method. Here we also add a legend to the plot. Here instead, you can see how we can add some custom labels to the plot. With subplots, we can draw multiple plots in the same figure. We just have to call the subplot method before each plot we add. This method takes 3 arguments: the number of rows, the number of columns, and the index of the current plot. Here we created 2 different plots, with 2 different titles. Note that we can also add a superior title for the whole figure. Similarly, we can obtain a figure with 2 rows and 1 column. We can also add different types of grid to our plot background. Let's move on to the scatter plot, in which we draw a dot for each observation. We need 2 arrays of the same length. One array represents the values on the x-axis, while the second array represents the values on the y-axis. Here we use Numpy to generate the 2 random arrays of 20 elements. The first within the interval 0–100, the second between the interval 0–15. To draw a multi-scatter plot, we just have to call more times the same method. Here instead, we apply a color to the dots based on their y value. The CMap argument is used to specify a color map in which each color is represented by a value. The C argument is used to indicate for each dot which color to take from the color map. Typically, the color map is used to encode another dimension of the data, and not to encode another time the y values we have. The bubble plot is a variation of the scatter plot. Also with this plot, we can display 3 dimensions. The third dimension is encoded by the size of the bubble. Here we use the alpha argument to better visualize overlapping bubbles. By using both bubbles and colors, we can encode 4 dimensions, but this is not much readable. Here instead, we use the bar method to draw bar plots. These plots can be useful to visualize information about categorical variables, in this case simulated with 4 letters. This is the simple code to plot a histogram. The first line generates 1000 samples from a distribution with a zero mean and standard deviation equal to 1. Here instead, we draw two pie charts. We generate 4 random numbers between 1 and 10. Each number is associated with a label. The explode argument is used to separate the slices of the pie. In the box plot, the box extends from the lower quartile values of the data, 25%, to the upper one, 75%, with the line at the median. The whiskers are drawn to show the range of the data. Beyond the whiskers, we can find the outliers. Let's move on to the second visualization tool, Seaborn. It is a Python library built on Matplotlib, and that can be easily integrated with the Pandas dataframes. Here you can see how to import Seaborn and how to set its style for our plots. First of all, let's see how to draw a line plot with Seaborn. We have to use the relplot method, specifying the kind argument equal to line. Here we draw a regression model. We generate samples that follow a line with a random delta variation. We use different colors for the data and for the linear regression model. For this part of the lesson, we will use the Titanic dataset provided by the Seaborn library. This dataset contains information about the passengers of the Titanic. To visualize the relationships between the features of the data frame, we can use a scatter plot. Here we visualize the relationships between the age of the passengers and the ticket price they paid. The age of the passengers is not a great discriminant for the ticket price. Note that we can specify the data frame as the data argument, and then for x and y we can specify the data frame columns we are interested in. We can also draw a different plot based on the values of a third column. In this case, we create a different plot based on the sex column values. We can specify if we want to draw the plot on different columns or rows. Here we apply the same idea, but using both the col and the row arguments for two different data frame attributes. Also with Seaborn, we can use colors to encode the third dimension of the data. We have to use the hue argument. Note how it is easier to obtain this result in Seaborn with respect to Matplotlib. Instead of colors, we can encode the third dimension also with the style or the size of the dots. Of course, we can combine the arguments we have already seen. We can use the count plot to count the number of male and female passengers, starting from the data frame columns. By adding the survived column as y, we can see the percentage of males and females that survived. By leveraging the hue argument, we can plot interesting information based on the sex and the class of the survivors. Thanks to a category plot, we can draw the same information but in separate plots. Also with the distribution plot, we can count the data frame entries with the same value on a specific column. By properly using the stat argument, we can normalize the counts so that the area of the histogram is 1. By default, the this plot will draw a histogram. By defining the stat argument as density, in this case we can see the percentage of people with a specific age within the data frame. The KDE argument can be used to estimate a line that follows the distribution. Let's use now colors to encode also the information related to the class. Here, the shrink argument is used to separate the bars of the plot. The multiple argument instead is used to define how to handle the hue dimension for each bar. In this case, we stack the representation of the different classes. To obtain a multiple bar plot, we can use instead the dodge parameter. Finally, to draw a box plot, we can use again the category plot method with the kind argument set to box. The last thing we see about Seaborn is the creation of heatmaps. First of all, Let's load again the Boston house prices dataset. We can use the Pandas core method to obtain a table that represents the relationships between each couple of DataFrame columns. This relationship is expressed by the Pearson correlation. The values of the table vary from -1 to 1. 1 means that there is a perfect positive correlation between two columns. When the value of one column increases, also the value of the other column increases. 0 means that there is no correlation between two columns. Finally, -1 means that there is a perfect negative correlation. When the value of one column increases, the value of the other column decreases. We can better visualize this table with an heat map. For simplicity, let's consider only a subset of the columns. We can use the heat map method to associate a color with each value of table C. The vmin and vmax arguments are used to specify the minimum and maximum values we want to associate with a color. The unknown argument is used to add the text representing the value of each cell of the table. The square argument is used to represent the table as a square. The mask argument is used in this case to cover the upper right corner of the table, since it mirrors the bottom left corner. The zeros-like method returns an ND array of zeros with the same shape of table C. The true indices from method instead returns the indices related to the upper triangle of the mask variable. In this way, we can cover the top right corner of the table. Thanks to the heat map, we can see that there is a positive correlation between the number of rooms, RM, and the price. On the other hand, there is a negative correlation between the percentage of the lower status population, LSTAT, and the price. Okay, now we can move on to the next library, WordCloud. This is a very easy to use library to create the world's cloud images. Here we import from the library the WordCloud method and the list of stop words. The stop words are the common words of a language that are typically removed before the analysis of a text. Some examples of English stop words are the, is, at, and that. This is the code to display a WordCloud image. First of all, we define a text variable we want to apply the WordCloud method to. Since the text variable contains a Latin text, we add some Latin words to the stop word set. Then we can use the WordCloud method. We define the width, the height, and the margin of the WordCloud image. We also specify the stop word set and the background color. Then we call the generate method with the text variable as argument. Finally, we just have to display the image thanks to the ImageShow method of Matplotlib. Volume is the last library we see in detail in this lesson. It is very useful to visualize data on a map. This is the code to import the library. This is the code to create a map centered on Rome. We can specify the width, height, and starting zoom of the map. With the tiles argument, we can specify the representation style of the map. This instead is the code to add two different kinds of markers on the map. The marker method is used to create a colored icon marker on the Colosseum. When this marker is clicked, a pop-up will show up with the text Colosseum. Note that we have to call the addTo method to add the marker on the map. The circle marker method instead is used to create from scratch a marker. In this case, we specify the radius, the color, and the fill color. The coolest thing to do with volume is drawing a choropleth. The idea is to color different areas of the map based on statistical data. First of all, let's import GeoPandas, a library used to handle data frames containing geometry data. Here we load a data frame containing geometry data related to the Italian regions. Let's make some pre-processing on the data frame. Here we rename the column which contains the name of each region, and we also remove possible duplicates. Then we drop the entries which contain data related to the entire Italy. These are the entries in which the region name is Intero Territorio Nazionale. We also change the name of two regions accordingly to the names we will find in another data frame we will use later. Finally, we sort the entries based on the region name. We select only the columns we are interested in, and we reset the entries indices of the data frame. Now we can load a data frame containing data related to the Italian COVID situation of a specific day. Also in this case, we rename some columns' name. Then we select only a subset of the data frame columns. Since to draw the choropleth we need both geometric and statistical data, we add the total positives column to the data frame that contains the geometric data. We use the geometric data frame since we still need a GeoPandas data frame to handle the geometry values. Then we create the map as we have already seen before. Hence, we can add the choropleth to the map. The geodata and data arguments require the geometric and the statistical data, respectively. Automatically, the library will take the geometry column of the data frame to create the region's boundaries. The columns argument requires a column as key and another column as values. The field color argument is used to specify the color map associated with the values of the column chosen as values. Another cool thing is to make the map interactive. Here we add to the map an interactive GeoJSON object. The map will show up a pop-up when we pass over a region with the mouse. The style function defines the basic style of this object. In this case, we use a white field color with a low opacity not to affect the color map of the choropleth. The highlight function defines the style of the object when we pass over it with the mouse. In this case, the region will be black colored. The tooltip argument is used to define the pop-up. Here we ask the library to display the total positives and the region name associated with the region. We just shortly introduce two more libraries. The Scikit-Learn library contains algorithms and useful tools for machine learning. We will use it in this course to build a machine learning pipeline. The Keras library instead is a very easy to use library you can use to build deep learning solutions. We will talk about it in other courses related to deep learning and neural networks. We arrived at the end of this lesson. See you in the next session of the course, where we will learn more about the machine learning pipeline.